You are sitting in a room that feels stable. The floor beneath you does not drift. The walls do not stretch. The air around your body behaves exactly as you expect it to. Your weight has a direction. Your thoughts follow time in a single line. Nothing about your immediate surroundings suggests that anything is wrong. You assume the universe is large, but not personally intrusive, vast, but safely distant. You assume that space expands far away from you, not through you. You assume that when scientists speak about scale, they mean distances measured in light years, not structures that quietly undermine the idea of location itself. This confidence rests on an assumption so basic you rarely notice it, that the universe has a size that could, at least in principle, be described, that it has an outside or a boundary or a total extent, that when we speak about everything, we are referring to a single coherent object. But modern physics does not actually guarantee this. Some of the most serious models in cosmology suggest that space may not simply be big, but unbounded in ways that break intuition, that the universe may repeat without repeating, that what you observe may be a tiny local patch of something that cannot be surveyed, counted, or even meaningfully totaled, that the word universe may not refer to a single entity at all. What follows is not science fiction. It is the consequence of equations that work, of observations that have been verified, of theories developed to explain data, not to disturb you. The question is not how big the universe is. The question is whether scale itself still makes sense. The illusion of a single universe. You tend to imagine the universe as one thing, a single connected expanse containing all matter, all energy, all events. This feels obvious because everything you can observe belongs to the same visible structure. Galaxies cluster together. Physical laws appear uniform. Light behaves consistently in every direction you look. But this coherence may be local. Modern cosmology allows for the possibility that what you call the universe is only one region within a far larger framework, not separated by walls or edges, but by causal disconnection. Other regions may exist that obey the same equations, yet can never exchange information with you. Not now, not ever. If that is true, then the word universe no longer means everything. It means everything you can, in principle, be affected by. And beyond that boundary, scale loses its meaning. This idea is difficult to accept because your experience encourages the opposite assumption. Everywhere you look, the same rules apply. Gravity pulls the same way. Atoms behave the same way. Time flows forward at the same pace. Uniformity suggests unity. It feels reasonable to conclude that what you observe is representative of the whole, but observation does not grant access to the whole. It grants access only to what light has had time to reach you from. The visible universe is not defined by edges in space, but by limits in time and causality. There may be regions that are just as real as your own, governed by the same underlying physics, yet permanently unreachable. Their existence would not violate any known law. It would follow directly from them. In this framework, separation is not spatial in the ordinary sense. You do not need distance in the usual way to be isolated. Expansion itself can create permanent disconnection. Space between regions can grow faster than information can travel. Once that happens, no signal, no particle, no influence can ever cross the gap. From your position inside one region, everything still appears unified. The illusion persists because nothing within your horizon contradicts it. But unity here does not imply unity everywhere. Coherence does not scale indefinitely. If the universe is structured this way, then your intuition has quietly overreached. You have mistaken a local patch for the totality of existence. What you call everything may be closer to a neighborhood, and beyond it, not emptiness, but continuation without contact. The unsettling implication is not that other regions exist, it is that their existence changes nothing for you. They do not threaten your reality. They do not interact with it. They simply render the idea of a single, all-encompassing universe unnecessary. What remains is a quieter realization that what you mean by universe depends entirely on where you are, and that the word itself may never have referred to a single thing at all. Space that does not end. It feels natural to ask where the universe ends. This question assumes that space behaves like an object with edges, but general relativity does not require space to terminate. It allows for space that is finite, yet unbounded, or infinite without repetition, or infinite with repetition. In some models, if you traveled far enough in a straight line, you would never encounter a boundary. Space would continue indefinitely, without thinning, without breaking, without changing its local properties. Expansion would not push you toward an edge. It would simply generate more distance between everything. An infinite universe does not announce itself as infinite. Locally, it looks exactly like a finite one, and that means you have no observational way to confirm whether space ever stops. Your intuition resists this because you are trained by objects. Every physical thing you interact with has a surface. Rooms have walls. Roads have ends. Even the planet you live on curves back on itself in a way that still feels contained. You expect space itself to behave in a similar way, as if it must eventually give way to something else. But space is not an object embedded in a larger container. It is the container. Asking what lies beyond it assumes an external reference frame that the theory does not provide. In general relativity, space does not sit inside anything. It is not surrounded. It is described internally by its geometry, not by its boundaries. This allows for possibilities that feel counterintuitive, but remain mathematically consistent. Space can be finite without having an edge, like the surface of a sphere. You can travel indefinitely without ever crossing a boundary, yet the total area is limited. Or space can be infinite, extending endlessly in all directions, never looping, never terminating. Both scenarios obey the same local physics. What makes this unsettling is that no experiment you can perform from within space can definitively distinguish between these options. Measurements of curvature can suggest certain geometries, but expansion complicates them. As space stretches, any global structure is pushed beyond reach faster than you can observe it. If space is infinite, then every region you could ever reach is surrounded by more of the same. No thinning, no fade, no transition into something else. Distance loses its role as a path toward completion. There is no final horizon where the universe resolves into an answer. Even if space is finite, its closure may be so large that it is functionally infinite from your perspective. The difference becomes philosophical rather than practical. You live inside a system whose total extent may be fundamentally inaccessible to you. The deeper implication is not about size, but about limits of knowledge. You may exist in a universe that does not end, and you would have no direct way of knowing. Your evidence would always be local. Your conclusions would always extrapolate. In such a universe, scale is not something you can fully grasp. It is something you infer without closure. Space does not offer you an ending. It offers only continuation, and with it, the quiet possibility that there is no final place for reality to arrive. the horizon you cannot cross. There is a limit to what you can see, not because the universe ends, but because light has only had a finite amount of time to reach you. This boundary is called the cosmic horizon, and it defines the maximum distance from which information can arrive. Beyond this horizon, galaxies still exist. Physics still operates. Time still passes, but none of it can influence you. Those regions are not merely far away, they are causally inaccessible. If space is infinite, then beyond your horizon lies an endless expanse of unseen structure. Not empty, not hypothetical, simply unreachable. Your observable universe is not the universe. It is a temporary bubble of visibility moving through something far larger. You are accustomed to thinking of distance as something that can always be crossed given enough time. Mountains can be climbed. Oceans can be crossed. Even distant planets feel reachable in principle, limited only by technology. The cosmic horizon violates this expectation. It is not a technological barrier. It is not a temporary obstacle. It is a limit imposed by the structure of space-time itself. Light travels at a finite speed. This is not a convenience or a constraint that can be engineered around. It is a fundamental feature of reality. Because the universe has a finite age, there are regions from which light has simply not had time to arrive. Those regions are not hidden. They are not blocked. They are just too far back in time. As the universe expands, this horizon behaves in an unintuitive way. New regions constantly enter your observable universe as their light finally reaches you. At the same time, other regions are carried away by expansion so rapidly that light emitted now will never arrive. Visibility grows and shrinks simultaneously, not because objects move, but because space itself stretches. This creates a subtle but profound separation between existence and influence. Something can exist without ever being able to affect you. It can have mass, energy, structure, and history, and still be permanently irrelevant to your future. Not because it is insignificant, but because causality does not extend that far. You might imagine that given infinite time, all horizons dissolve. But expansion prevents this. In many cosmological models, the universe expands in such a way that some regions recede faster than light can traverse the growing distance. This does not violate relativity, because it is space that expands, not objects moving through it. The result is permanent disconnection. From your perspective, this means that reality is larger than your causal reach in a way that can never be corrected. No observation strategy, no signal, no future advancement allows you to bridge that gap. The universe you can interact with is only a subset of what exists. This reframes what it means to know something. Every cosmological model you construct is based on a limited sample. You extrapolate from what you can see, knowing that what lies beyond may follow the same rules or may not. You assume continuity because it works locally, not because it has been verified globally. The horizon also moves relative to you. As time passes, the observable universe changes, not dramatically on human timescales, but inevitably. What you call everything is time-dependent. It is defined by when you exist, not just where. The unsettling implication is that there is no fixed inventory of reality available to you. The universe does not present itself all at once. It reveals fragments, governed by timing rather than permission. What remains unseen is not waiting for discovery. It is already lost to you. You live inside a bubble that feels complete because nothing inside it contradicts that feeling. But completeness here is an illusion created by limits. Beyond your horizon, The universe continues without reference to you, indifferent to whether it is ever observed. Repetition without contact. In an infinite universe governed by finite physical laws, patterns must eventually repeat, not symbolically, literally. The number of possible configurations of particles within a given volume is enormous, but finite. Given infinite space, those configurations recur. Somewhere far beyond your horizon, there may exist regions identical to your observable universe down to the smallest detail. There may be another Earth, another room, another version of you reading this exact sentence. These regions are not alternate realities. They follow from the same space and the same laws. They are simply too distant to ever interact with you. Repetition emerges not from design, but from scale. This conclusion feels unsettling because it collides with a deeply held assumption that what happens here is unique. You experience your life as a one-time event unfolding along a single path. History feels irreversible. Identity feels singular. Repetition, when it occurs, feels intentional or artificial. But infinite space does not require intention. It requires only allowance. Physical law constrains how matter can arrange itself. Particles have limited states. Fields take on values within ranges. Even when randomness is involved, it operates within boundaries. The result is that, within any finite region of space, there is a maximum number of distinct physical arrangements that can exist. The number is vast beyond comprehension, but it is not infinite. If space extends without bound, those arrangements cannot remain isolated forever. Given enough volume, every permitted configuration occurs again, and again, and again, not clustered together, not patterned neatly, but scattered across distances so immense that no signal could ever bridge them. This does not require exact symmetry across the entire universe. It requires only local repetition. A region large enough to contain everything you can observe, reproduced elsewhere by chance, governed by the same equations, evolving through the same sequence of events. The distances involved matter. These copies would not be nearby. They would not lie just beyond your horizon. They would be separated by expanses so large that the word distance loses its practical meaning. You could travel forever and never approach them. They exist in the same universe, but not in the same causal network. This distinction is critical. Repetition does not imply connection. These are not parallel timelines. They do not branch from your choices. They do not diverge based on decisions you might have made. They evolve independently, starting from identical conditions, but remaining forever unaware of each other. This reframes the idea of uniqueness. You may be locally unique, but not globally so. Your exact configuration may be rare within your horizon, yet inevitable across infinite space. Identity becomes a matter of position, not exclusivity. The discomfort comes from realizing that nothing about you prevents this. There is no physical principle that singles you out, no conservation law that protects singularity. The universe does not track instances. It allows configurations to exist wherever conditions permit. From your perspective, this repetition has no observable consequence. You will never meet these counterparts. You will never exchange information. Their existence does not affect your future or your past. And yet, conceptually, they exist as fully as you do. This creates a quiet tension between experience and explanation. You feel singular because your experiences are continuous and unshared. Physics, however, does not care about that continuity. It accounts only for states and transitions, not for narrative. The tension deepens when you consider that these identical regions are not static copies frozen in time. They evolve. If the initial conditions truly match, then their histories unfold in lockstep, at least for a while. The same stars ignite. The same planets form. The same biological processes begin. The same thoughts arise. Eventually, microscopic differences may emerge. A quantum fluctuation, a thermal variation, a divergence so small it cannot be anticipated. From that point on, the paths separate. But until then, repetition is exact, not approximate. What this removes is the idea that events happen once because they are special. They happen once here because you occupy this location. Elsewhere, they happen again for the same reason. The universe does not economize on outcomes. It does not preserve novelty. It exhausts possibility. You remain confined to one instance, one location, one sequence of events. Beyond your horizon, the same story may be unfolding without variation, not as a reflection of you, and not as a consequence of choice, but as a consequence of scale that does not distinguish between occurrences. Repetition, in this sense, is not a feature added to reality. It is what remains when nothing forbids it. Inflation that never stopped. The early universe underwent a period of rapid expansion known as inflation. This theory explains why space appears uniform and flat on large scales, but some versions of inflation do not end everywhere at once. In eternal inflation models, inflation continues indefinitely in most regions, spawning pocket universes where it locally stops. Each pocket becomes its own expanding cosmos. Your observable universe may be one such pocket. If this is correct, then space is not merely infinite. It is constantly generating new regions faster than they can ever connect. Scale is not static. It is actively growing beyond comprehension. You are accustomed to thinking of expansion as something that happened once, long ago, and then slowed into a quieter evolution. Inflation disrupts that narrative. It suggests that the universe did not simply begin and settle. It fractured. And in many regions, it never finished doing so. Inflation was introduced to explain a specific problem. When you look at the universe on the largest scales, it appears remarkably smooth. Regions separated by vast distances share nearly identical temperatures and properties, even though there should not have been enough time for them to exchange information. Inflation resolves this by proposing that those regions were once close together before space expanded explosively. But the same equations that make inflation work do not require it to end everywhere. In some solutions, inflation is self-sustaining. As it ends in one region, creating a pocket universe like yours, it continues elsewhere. The background keeps expanding, spawning new pockets endlessly. From the inside, a pocket universe looks complete. Space expands, galaxies form, time flows forward. Nothing about your local environment reveals that it is embedded within a larger inflating structure. The process that created your region leaves no obvious signature of its continuation beyond it. This is what makes eternal inflation unsettling. It does not describe a single universe with a beginning and an evolution. It describes a process that generates universes as outcomes. Your cosmos becomes one event among infinitely many, not the stage on which all events occur. Scale behaves differently in this picture. It is not something you measure after the fact. It is something being produced. New regions of space are created faster than causal contact can keep up with them. Disconnection is not accidental. It is built into the dynamics. You cannot trace a path from your region to the others. There is no direction you could travel that leads outward into the inflating background. The separation is not spatial in the ordinary sense. It is embedded in the way time and expansion interact. Once inflation isolates a pocket, it remains isolated forever. This reframes what it means to ask how large the universe is. There may be no fixed answer. The total volume of inflating space increases without bound. The number of pocket universes grows without limit. The structure does not converge on a final state. From your position, this means that the universe you inhabit is not the whole of reality, but a local outcome of a larger process that does not privilege you. Your laws of physics may be stable because inflation ended in a particular way here. Elsewhere, the ending may differ. Eternal inflation also complicates explanation. If every allowed outcome occurs somewhere, then the fact that you observe this particular universe requires additional reasoning. You exist in a region compatible with your existence, but that compatibility is no longer rare. It is guaranteed by scale. The unsettling implication is subtle. It is not that other universes exist, but that their existence is effortless. Reality does not struggle to produce variety. It generates it continuously, without coordination, without memory, without selection beyond what can locally persist. You are inside a universe that looks self-contained, yet maybe only a byproduct, a region where inflation happened to stop, temporarily stabilized, and allowed structure to form. Beyond it, the process continues, indifferent to the outcomes it leaves behind. Scale, in this picture, is not something you can step back and survey. It is something that outruns any attempt to contain it. The universe does not finish expanding. It does not settle into a final arrangement. It keeps producing space faster than meaning can keep up, and you remain inside one pocket of that process, measuring distances, ages, and sizes, while the larger structure that made them possible continues without ever becoming accessible to you. Universes with different physics. In some inflationary models, each pocket universe may settle into different physical parameters, different constants, different particle properties, different dimensional structures. You experience physics as fixed because your region stabilized in a particular way, but elsewhere, the same underlying equations may produce radically different outcomes, not because of chaos, but because the solution space allows it. If this is true, then the laws you rely on are local facts, not universal truths. Scale does not just multiply space, it fragments consistency. Your confidence in physical law comes from repetition. Every experiment you perform yields the same result. Electrons behave the same way. Gravity follows the same equations. The constants that define interactions do not drift. Stability creates the impression of necessity, as if these values could not have been otherwise. But modern theoretical physics does not require that conclusion. Many of its most successful frameworks permit a wide range of possible outcomes. The equations allow different solutions, each internally consistent, each capable of supporting structure, but incompatible with one another. What you experience as fixed may simply be frozen. In inflationary cosmology, this freezing happens when a region of space exits inflation and settles into a particular vacuum state. That state determines which particles exist, how forces behave, and how many dimensions are active. Once set, these properties remain stable within that region. But the same process, occurring elsewhere, may settle differently. This does not mean that physics breaks down. It means that physics is deeper than the laws you observe. The apparent laws are emergent consequences of a particular configuration, not the fundamental rules themselves. What is fundamental may be the space of possibilities, not the outcome you inhabit. From your perspective, this introduces an unsettling contingency. The strength of gravity, the mass of the electron, the value of the cosmological constant feel finely tuned. Small changes would render stars unstable, chemistry impossible, life unviable. This sensitivity has often been interpreted as evidence of necessity or design. In a multiverse produced by inflation, it has a different explanation. Every permitted set of values exists somewhere. You find yourself in one that allows observers because only such regions can be observed. The tuning does not reflect intention. It reflects selection by existence. This shifts the meaning of explanation. Instead of asking why the constants have these values, the answer becomes that they had to have some values, and you can only observe those compatible with your presence. Explanation moves from law to location. The fragmentation of physics also undermines the idea of a single, unified description of reality. There may be no set of constants that apply everywhere, no final list of parameters to be measured and explained. The underlying theory may describe how possibilities arise, not which one is realized. This creates a subtle loss of universality. When you say a law is true, you may mean only that it is true here. Beyond your region, the same statements may be meaningless or false. Even concepts like particle, force, or dimension may not generalize. You cannot verify this directly. Regions with different physics would be causally disconnected from you. Their existence would leave no trace in your data. Yet their possibility follows naturally from theories developed to explain observations within your own universe. The unsettling implication is not that your physics is wrong. It works exactly where you are. The implication is that it may not be privileged. It may not be the default structure of reality. It may be one outcome among many, stabilized by circumstance rather than necessity. You rely on physical law to anchor your understanding of the world. It tells you what can happen and what cannot. In a multiverse of varying physics, that boundary becomes local. Possibility expands beyond your horizon, unconstrained by the constants you treat as absolute. Scale, in this sense, does not just make the universe bigger, it makes it less uniform. It replaces a single coherent order with a patchwork of consistent but incompatible realities, each obeying its own rules, each unaware of the others. You exist within one such patch, interpreting its stability as inevitability. But beyond your reach, physics may operate under conditions so different that even the concept of law, as you understand it, no longer applies. The measure problem. If there are infinitely many regions and infinitely many types of outcomes, then probability itself becomes unstable. How do you compare infinities? How do you say what is typical when everything happens endlessly? This is known as the measure problem in cosmology. Without a way to weight infinite outcomes, predictions lose meaning. Theories can describe everything, but explain nothing. Scale, when taken to infinity, erodes the concept of likelihood. Existence becomes statistically ambiguous. You rely on probability more than you realize. Every prediction you trust, every explanation that feels satisfying, assumes that some outcomes are more likely than others. When a theory works, it does so by telling you not just what can happen, but what usually happens. Probability gives structure to uncertainty. It allows expectation. Infinite cosmology disrupts this foundation. If every allowed outcome occurs infinitely many times, then counting no longer works. There are infinitely many regions where stars form, and infinitely many where they do not. Infinitely many observers like you, and infinitely many radically unlike you. Any ratio you try to compute becomes undefined. Infinity divided by infinity does not resolve into meaning. This is not a philosophical quirk. It is a technical problem that appears inside otherwise rigorous models. Eternal inflation, multiverse scenarios, and infinite spatial extensions all generate unbounded numbers of events. To make predictions, cosmologists must decide how to compare them. That decision requires a measure, a rule for weighting infinite sets, but no unique measure is dictated by the theory. Different ways of regulating infinity produce different answers. In one measure, your universe looks typical. In another, it looks extraordinarily rare. In a third, observers like you should not exist at all. The underlying physics remains the same. Only the bookkeeping changes. This means that prediction becomes sensitive to assumptions that have no empirical justification. You can alter conclusions without altering equations, simply by changing how you count. Explanation slips away from observation and into convention. From your perspective, this undermines confidence in cosmological reasoning. You observe a universe with certain properties and ask what it implies about reality as a whole. But if typicality cannot be defined, then observation loses its inferential power. Seeing something does not tell you whether it is common, rare, or inevitable. The measure problem also destabilizes the concept of explanation itself. Normally, when a theory predicts an outcome with high probability, you feel justified in accepting it. When it predicts an outcome with low probability, you question it. In an infinite universe, every outcome has probability 0 or undefined, depending on how it is framed. Nothing is unlikely. Nothing is typical. Everything happens endlessly. Outines are possible. But none can be said to dominate. This leads to a quiet collapse of expectation. You still experience a coherent world. Events still follow patterns locally. But globally, there is no statistical anchor. The universe does not prefer certain outcomes over others in a way that can be cleanly articulated. You may try to escape this by restricting attention to your observable region. But the theories that motivate the measure problem do not stop there. They assert that what you see is embedded within something much larger. Ignoring that context restores probability only by discarding the theory. The unsettling implication is that some cosmological models may be empirically complete, yet explanatorily hollow. They accommodate every observation without privileging any. They fit the data, but they do not tell you why this data, rather than any other, appears. In such a framework, your existence ceases to be informative. It does not confirm or disconfirm the larger structure. It merely occupies one point in an unweighted expanse of possibilities. Scale, taken to infinity, does not just stretch the universe. It stretches reasoning itself until distinctions blur. Probability, which once guided understanding, becomes a local convenience rather than a global principle. You continue to ask what is likely. The universe, at infinite scale, no longer answers that question. You, as a statistical fluctuation. In an infinite universe, rare events occur infinitely often. This includes spontaneous configurations of matter that momentarily resemble conscious observers, known as Boltzmann brains. These hypothetical entities arise from thermal fluctuations in vast expanses of space. They possess memories, perceptions, and self-awareness, but no history. If infinite time and space exist, then Boltzmann brains vastly outnumber evolved observers. This raises a disturbing question. What makes you confident that you are not one? You normally assume that your thoughts are the result of a long causal chain, a universe that cooled, stars that formed, chemistry that stabilized, biology that evolved, brains that developed through selection and history. Your memories feel grounded because they are embedded in a narrative of gradual construction. Boltzmann brains challenge this assumption at its root. In statistical mechanics, thermal fluctuations are unavoidable. Given enough time, particles occasionally arrange themselves into highly ordered configurations by chance alone. Most of these configurations are trivial and fleeting. But in an infinite universe that persists indefinitely, even extremely improbable arrangements occur, not once, but endlessly. A Boltzmann brain is one such arrangement, a self-aware structure assembled spontaneously from chaos, complete with neural states that encode memories, beliefs, and perceptions. Those memories may include childhood, education, relationships, even cosmology. From the inside, the experience is indistinguishable from yours. The critical difference is that none of it happened. There was no past that produced those memories, no environment that shaped them. The brain fluctuates into existence fully formed, persists for a brief moment, and then dissolves back into disorder. Its experiences are internally coherent, but externally uncaused. In a universe of finite age and size, this possibility is negligible. But in a universe that is infinite in space or time, negligible does not mean impossible. It means inevitable. And once inevitability enters, frequency follows. Evolved observers like you require extraordinary conditions, stable stars, complex chemistry, billions of years of planetary history, and delicate biological processes. Boltzmann brains require only time and randomness. Given enough of both, they become far more common. This creates a statistical inversion. If you randomly sampled a conscious observer from such a universe, it would almost certainly be a Boltzmann brain rather than an evolved being. Not because Boltzmann brains are favored, but because they are cheaper to produce in infinite time. The unsettling implication is not that Boltzmann brains exist. It is that their existence undermines your confidence in your own origin. If most observers are fluctuations with false memories, then having memories is no longer evidence of a real past. You may try to reassure yourself by appealing to coherence. Your experiences are continuous. Your world is stable. But a Boltzmann brain can experience continuity too, encoded in its neural state. Stability, from the inside, does not require an external cause. You may appeal to probability. Surely it is unlikely that you are a fluctuation. But probability itself becomes suspect in infinite models. If Boltzmann brains vastly outnumber observers like you, then typicality works against you. You may appeal to duration. You have persisted for years, not moments. But the brain that fluctuates into existence can encode the belief that it has persisted for years. Subjective time does not map cleanly onto physical time. The only remaining defense is theoretical. Some cosmological models avoid Boltzmann brain domination by ensuring that ordinary observers remain more common, or that the universe does not last long enough for fluctuations to dominate. These constraints are taken seriously, not because Boltzmann brains have been observed, but because their dominance would undermine the coherence of explanation itself. This reveals the deeper tension. Boltzmann brains are not troubling because they are grotesque. They are troubling because they force you to confront what justifies belief in history at all. If experience can arise without cause, then evidence loses its grounding. You continue to trust your memories because rejecting them collapses meaning. But in an infinite universe, that trust becomes an assumption, not a conclusion. The question remains unresolved. You experience yourself as the product of a long chain of events. Physics allows the possibility that experience does not require such a chain. Between those two facts lies a discomfort that cannot be dismissed by observation alone. You feel real. You feel continuous. You feel embedded in time. Boltzmann brains feel the same. The end of typicality. You assume your experience is typical, that your environment reflects a common outcome of physical processes. But infinite scale undermines this assumption. In a universe where every configuration exists endlessly, there is no privileged observer, no baseline experience, no natural reference class. Typicality becomes undefined, and without typicality, reasoning from observation becomes unreliable. Much of what you believe about reality rests on an unspoken inference that what you observe is not exceptional. You look at the sky, the structure of matter, the flow of time, and you assume these features are representative. You infer laws from regularities and trust them because they appear stable and widespread. This inference works in finite systems. When outcomes are limited, frequency has meaning. You can say what usually happens and what rarely does. Typicality gives observation its power. It allows you to move from what you see to what exists. Infinite scale dissolves that bridge. If the universe contains infinitely many regions, then every allowed configuration occurs endlessly. Every environment you can imagine is instantiated somewhere. Every deviation, no matter how extreme, is repeated without bound. In such a setting, the notion of a common outcome loses coherence. There is no fact of the matter about what most observers experience. For every observer in a stable, orderly universe, there are infinitely many and chaotic or transient ones. For every long-lived civilization, there are infinitely many brief or malformed counterparts. Counting does not converge. Ratios do not settle. This removes the idea of a natural reference class. When you ask whether your experience is typical, the question assumes a comparison group. But infinite reality does not supply one. Any group you define can be outnumbered by another, equally infinite group defined slightly differently. From your perspective, this creates a quiet epistemic instability. You observe a universe with certain properties and infer that those properties are explanatory. But if typicality cannot be defined, then observation alone cannot justify that inference. Seeing something no longer tells you whether it is representative or exceptional. This affects even the most basic assumptions. You assume that the laws of physics you observe are common, that the arrow of time you experience is standard, that your position in cosmic history is unremarkable. Infinite scale turns all of these into unsupported assumptions. The problem is not that your experience is misleading. It is that it may be unclassifiable. In finite cosmology, observers can be ranked by frequency. In infinite cosmology, every ranking depends on arbitrary cutoffs. Where you place those cutoffs changes the answer. Typicality becomes a matter of convention, not discovery. This leads to a deeper consequence. Scientific reasoning relies on the idea that observations can confirm or disconfirm theories. But if a theory predicts that all possible observations occur infinitely often, then no observation favors it over its alternatives. The theory becomes observationally saturated. You can still build models. You can still match equations to data. But explanation weakens. The universe stops telling you what is normal. From the inside, nothing feels wrong. Your world remains coherent. Events follow patterns. Causes produce effects. But the global context that once justified trusting those patterns dissolves into unbounded variation. You may try to restrict attention to your observable region. Locally, typicality seems to hold. But the theories that introduce infinite scale do not permit that restriction. They assert that what you see is embedded in something far larger. Ignoring that embedding restores typicality only by discarding the model. The unsettling implication is not that your observations are false. It is that their interpretive power may be limited. You can describe what happens here. You may not be able to say what usually happens anywhere. In a universe without typicality, explanation becomes local and provisional. Knowledge loses its claim to generality. You understand your environment, but not its place. You continue to reason as if your experience is a reliable guide to reality. You have no alternative. But infinite scale removes the guarantee that this reasoning extends beyond your horizon. You are not misled. You are unanchored, and in that condition, certainty becomes a habit rather than a conclusion. Geometry that wraps around itself. Space may be finite without boundaries, like the surface of a sphere, but in higher dimensions. If this is the case, traveling far enough in one direction could eventually return you to your starting point. But expansion complicates this picture. The path back stretches faster than you can move. The geometry exists but remains practically inaccessible. Scale hides structure not by removing it, but by placing it beyond reach. You are used to thinking of finiteness as enclosure. If something is finite, you expect an edge, a wall, a place where continuation stops. Geometry undermines this expectation. It allows spaces that are limited in total extent, yet possess no boundaries at all. On the surface of a sphere, there is no edge. You can walk forever without encountering a border, yet the area you traverse is finite. Every direction eventually curves back on itself. No external reference point is required. The surface is complete without being enclosed by anything else. Cosmology permits similar structures for space itself. Three-dimensional space may curve in ways that make it finite, but unbounded. You could, in principle, travel in a straight line and return to your starting location without ever turning around. There would be no marker to indicate that you had circled anything. Locally, space would feel ordinary at every point. This possibility does not contradict observation. Locally curved and globally wrapped spaces can appear nearly flat over observable distances. The curvature radius may be so large that all measurements within your horizon detect only near-flat geometry. The wrapping exists, but it is too subtle to register. Expansion changes the implications. Even if space wraps around, it may be expanding so rapidly that the return path grows faster than any signal or object could traverse it. The geometry allows closure, but dynamics deny access. What is mathematically connected becomes physically unreachable. This creates a peculiar form of isolation. You may inhabit a finite universe that you can never circumnavigate. The total structure exists, but no observer can trace it. The universe may close in on itself in ways that are permanently hidden by expansion. From your perspective, this is indistinguishable from infinite space. You never encounter repetition. You never see yourself from behind. You never detect the global topology. The distinction exists only in theory, not in experience. This challenges the idea that structure must be discoverable to be real. The geometry may be fully determined, yet forever beyond observation. Space may have a shape that no experiment can reveal, not because of technological limits, but because of the way scale and expansion interact. In this sense, scale acts as concealment, not by erasing structure, but by diluting access to it. The universe can be finite without offering closure. It can be shaped without presenting form. The unsettling implication is that reality may be more orderly than you can ever know. There may be global constraints governing space that never manifest locally. You live inside a system whose totality is defined, but whose definition cannot be reconstructed from within. This undermines a quiet assumption that enough exploration reveals the whole. In wrapped geometries under expansion, exploration has a horizon that is not an edge, but a limitation of reach. You do not fail to find the boundary. The boundary never presents itself. You may try to imagine signals traveling faster, probes launched indefinitely, civilizations persisting for eons. None of this changes the outcome. Expansion scales distances in a way that preserves separation. The universe does not allow itself to be fully traced. What remains is a universe that may be finite, infinite, or something in between, without offering a decisive answer. Geometry suggests possibilities. Dynamics prevent confirmation. You exist inside a space that may loop back on itself in ways you can never follow. The path exists. The return is permitted by structure. But scale ensures that permission is never exercised. The universe does not hide its form by placing it behind a wall. It hides it by stretching the distance to comprehension faster than any observer can close it. Fractal cosmology. Some models suggest that the universe exhibits self-similar structure across scales, clusters within clusters, voids within voids, patterns repeating at different magnitudes. If scale is fractal, then there is no fundamental size at which structure ends. Every level reveals another layer of organization. The universe does not simplify when zoomed out. It becomes more complex. You are accustomed to the idea that complexity belongs to the small. Cells are complex. Molecules are intricate. At larger scales, you expect averaging, smoothing, simplicity. This expectation is reinforced by everyday experience. Fine details blur with distance. Patterns dissolve as you step back. Cosmology does not fully cooperate with this intuition. When astronomers map the distribution of galaxies, they do not see uniformity emerging cleanly with scale. They see filaments, walls, clusters, and vast empty regions arranged in repeating motifs. As surveys expand, new structures appear rather than resolving into homogeneity. Order gives way to larger order. Fractal cosmology explores the possibility that this behavior does not terminate. In a fractal system, patterns recur across scales without converging to a single characteristic size. There is no privileged level of description where structure stops and smoothness begins. Every zoom reveals another hierarchy. This does not mean the universe is exactly fractal in a strict mathematical sense. Observations suggest approximate self-similarity over certain ranges, but the deeper implication remains. Scale may not rescue you from complexity. Stepping back does not guarantee simplification. If the universe is organized this way, then your sense of orientation is misleading. You imagine that there is a largest structure, a final scale beyond which nothing new appears. Fractality denies this closure. There is always another layer, larger than the last, shaped by the same organizing principles. This reframes the meaning of size. Large does not mean simple. Vast does not mean empty. Expansion does not erase structure. It multiplies contexts in which structure can arise. Complexity is not confined to origins or endpoints. It persists. From your position, this undermines the idea of a cosmic overview. You cannot step far enough back to see the whole as a simple object. Any vantage point reveals only a fragment of an endlessly nested system. There is no scale at which the universe becomes a single, easily described thing. This has consequences for explanation. Scientific understanding often seeks compression, a small set of principles that explain large phenomena. Fractal structure resists compression. Descriptions remain scale-dependent. What explains behavior at one level may not dominate at another. You may attempt to locate a fundamental scale where the fractal behavior ends. Perhaps beyond some distance, uniformity finally asserts itself. Perhaps the largest scales smooth out, but even if this happens observationally, the absence of visible structure does not guarantee the absence of organization. Expansion and horizons limit what patterns you can detect. The unsettling possibility is that reality does not converge toward simplicity at the extremes. It may be complex all the way up, just as it is complex all the way down. The universe may not have a top level. This erodes a quiet narrative you rely on. That understanding increases as perspective widens. In a fractal cosmos, wider perspective does not grant mastery. It reveals repetition without resolution. You exist at one scale within this hierarchy, equipped to understand patterns that matter locally. Beyond that, patterns continue, indifferent to whether they can be summarized or not. There is no guarantee that a final description awaits discovery. Fractal cosmology suggests that the universe is not layered toward an endpoint. It is layered without end. Structure does not accumulate toward a final form. It reiterates. Zooming out does not bring you closer to an answer. It brings you into contact with a larger version of the same question. And in that repetition, scale ceases to function as a path toward clarity. It becomes a mechanism by which complexity sustains itself indefinitely. Time as a local feature. In an eternally inflating universe, time does not advance uniformly. Different regions experience different temporal histories. Some inflate forever, some settle, some collapse. Time becomes a patchwork property, not a global parameter. Asking what time it is in the universe no longer makes sense. Scale fractures chronology. You are used to thinking of time as universal, a single sequence that everything participates in. Even when clocks run at different speeds due to motion or gravity, you still assume there is a deeper ordering that places all events on one coherent timeline. Before and after feel absolute, even if they are distorted. Cosmology does not fully support this intuition. In models with eternal inflation, there is no single cosmic clock that governs all regions. Time behaves locally, defined by the physical processes occurring in each pocket universe. In some regions, inflation ends quickly, and ordinary cosmic evolution begins. In others, inflation never ends at all. Those regions do not age in any meaningful sense. They do not progress towards structure, decay, or equilibrium. They persist in a state without milestones. This means that time, as you experience it, is not a global feature of reality. It is a consequence of the conditions in your region. Your clocks tick because your universe settled into a state where entropy can increase in a familiar way. Elsewhere, that settling never occurs. The idea of asking what time it is everywhere becomes incoherent. There is no synchronized present across the total structure. No universal now. Events in different regions cannot be ordered into a single sequence because there is no shared temporal metric. Even within a single universe, general relativity already weakens the idea of global time. Different observers experience different rates of time depending on motion and gravity. Eternal inflation extends this fragmentation to the largest scales. Time ceases to be something that binds reality together. From your perspective, this destabilizes the notion of cosmic history. You speak about the age of the universe as if it were a single number. But in a multiverse context, that number applies only locally. Other regions have no age in the same sense. Some have infinite pasts, some have no meaningful beginning, some may end abruptly. This creates a universe without a shared story. You rely on time to make sense of causality. Causes precede effects, processes unfold, explanations trace sequences. When time fractures, causality becomes local as well. What causes events here may have no counterpart elsewhere. There is no global chain of cause and effect extending across all of reality. This also complicates the idea of prediction. You predict the future based on the past because you assume continuity. In regions where time behaves differently, continuity may not exist. The future there may not resemble the past in any structured way. The unsettling implication is not that your experience of time is false. It is real where you are. The implication is that it may not generalize. Time may be an emergent feature tied to particular physical conditions, not a fundamental backdrop against which everything unfolds. You exist in a region where time flows because entropy increases, structures form, and records persist. This flow feels universal because nothing in your environment contradicts it. But beyond your horizon, time may stagnate, branch, or fail to apply at all. In such a universe, there is no master timeline to consult, no overarching chronology to appeal to. Reality does not unfold in unison. It fragments into histories that cannot be synchronized. Scale does not just make the universe larger. It breaks the assumption that all parts of reality share the same temporal order. What you call the past and future are local labels, meaningful only within your pocket of space-time. You continue to measure time, to age, to remember, to anticipate. But the universe as a whole does not do these things. It does not have a present. It does not move forward. Time happens where conditions allow it. Everywhere else, it may not happen at all. Horizons within horizons. Just as you have a cosmic horizon, other regions have theirs. Each observer occupies a local bubble of causality surrounded by inaccessible space. There is no global perspective, no external vantage point from which the whole can be seen. Every view is partial by necessity. Scale eliminates objectivity. You tend to imagine that limitations are temporary, that with enough distance, enough time, or enough technology, a complete picture eventually emerges. This assumption is woven into how you think about knowledge. You picture an ideal observer who could, in principle, step far enough back to see everything at once. Modern cosmology removes that observer. Every observer, no matter where they exist, is surrounded by a horizon, a boundary defined not by ignorance, but by causality. Beyond it, events still occur, structures still form, and time still passes, but none of it can ever influence the observer inside. This is not a flaw in perspective. It is a structural feature of space-time. What makes this unsettling is that these horizons are not shared. Your horizon is not the same as anyone else's. Another observer, far away, has access to regions you can never see, while being equally blind to parts of your observable universe. There is overlap, but no total coverage. This means there is no location from which all horizons dissolve, no point where the entire structure becomes visible. Horizons do not stack neatly into a larger frame. They nest. Each bubble of causality contains smaller bubbles and is itself contained within larger unknowns. You might imagine combining observations, civilizations communicating, data being exchanged, maps being stitched together. But communication itself is bounded by horizons. Information cannot be relayed from beyond them, no matter how long you wait. The missing regions remain missing forever. This breaks a quiet assumption about objectivity. You often treat the universe as something that exists independently of perspective, with properties that can be fully specified. Horizons suggest otherwise. The universe may exist in its entirety, but no observer can access that entirety. Objectivity, understood as a view from nowhere, is unavailable. Instead, reality presents itself as a collection of overlapping but incomplete views. Each observer builds a model based on what lies within their causal reach. Those models may agree locally. They may even converge on shared laws, but globally, they are underdetermined. From your position, this introduces a fundamental humility. You are not merely limited in practice. You are limited in principle. There are truths about the universe that you cannot know, not because they are hidden, but because knowing requires access that cannot exist. The unsettling implication is that reality does not privilege coherence across perspectives. There is no guarantee that all local descriptions can be unified into a single global account. The universe may not be something that can be fully described from within. This does not mean your knowledge is false. It means it is situated. Your laws of physics work where you are. Your cosmological models describe what you can observe. Beyond that, extrapolation becomes assumption. You may try to imagine a higher-level description that transcends all horizons, but such a description would require information from beyond every causal boundary. There is no mechanism to obtain it. The universe does not offer itself as a completed object. Scale ensures this fragmentation. As space expands and regions disconnect, horizons proliferate. The larger the universe becomes, the more perspectives it contains, and the fewer of them can be reconciled. Objectivity, in the classical sense, relies on the idea that differences in perspective can be resolved by gathering more data. Horizons prevent this resolution. Some differences persist no matter how much data you collect. You live inside one bubble of causality, interpreting it as a world. Others live inside theirs, doing the same. None of these bubbles is privileged. None is central. None is complete. The universe does not present a single story to be discovered. It presents many partial stories, each bounded by horizons that cannot be crossed. Scale does not just limit what you can see. It limits what can be known at all. And within those limits, every claim to total understanding quietly dissolves. The loss of a center. There is no center of the universe, no preferred location. Expansion occurs everywhere at once. Every point moves away from every other point. On infinite scales, position loses significance. Location becomes relative without anchor. You are not near anything. You are not far from anything. You simply exist within a local patch. You instinctively search for a reference point, a middle, a place where things originate or toward which they converge. This instinct comes from living among objects. Rooms have centers, cities have downtowns. Maps place a marker and orient everything else around it. Cosmology offers no such marker. When you look out into space, galaxies recede in all directions. This recession does not point back to a single explosion site. It does not identify a location where expansion began. Instead, it reflects a property of space itself. Space expands uniformly. Every point experiences the same stretching. From every location, everything else appears to move away. This symmetry erases the possibility of a center, not because the center is hidden, but because the concept does not apply. Asking where the center of the universe is makes as little sense as asking where the center of a line that extends infinitely in both directions lies. Any point you choose can be treated as central, and none is privileged by the structure. You might imagine that the Big Bang marks a central event, but the Big Bang was not an explosion at a point in space. It was an event that occurred everywhere at once. Every region was once compressed, hot, and dense. Every region expanded. There is no spatial location you can point to and say it happened there. This removes a subtle psychological comfort. A center suggests hierarchy. It suggests orientation. It implies that distance from the center has meaning. Without a center, distance loses its narrative role. There is no deeper region toward which things trend, no outskirts where reality thins. In an infinite universe, this becomes even more pronounced. There is no boundary to measure distance from, no outer edge to define inside and outside. Every location is equally embedded. Position becomes a purely relational concept, defined only by what lies nearby. From your perspective, this means that where you are carries no cosmic significance. You are not close to anything fundamental. You are not far from anything essential. Your location is not distinguished by the structure of the universe itself. This is not the same as insignificance. It is neutrality. The universe does not assign importance through placement. It does not arrange itself around observers. It allows observers to arise wherever conditions permit, without central coordination. The loss of a center also removes the idea of a preferred frame of reference. There is no absolute rest frame relative to which all motion can be measured. Motion is always relative. Expansion does not privilege stillness anywhere. Everything participates equally. This challenges the idea that understanding improves as you approach some special vantage point. There is no place you could move to that would reveal the universe more clearly. No central observatory, no cosmic axis. Understanding does not correlate with position. The unsettling implication is that explanation cannot appeal to location. You cannot say things are the way they are because of where you are relative to some deeper structure. There is no deeper structure organized around a point. You exist within a local patch of space-time, shaped by nearby matter, governed by local conditions. Those conditions feel defining because they are all you experience. But they are not anchored to anything universal. This undermines the quiet idea that the universe has a natural orientation. Up and down dissolve. Center and edge dissolve. Near and far lose their intuitive hierarchy. What remains is a uniformity that does not guide interpretation. You may still draw maps. You may still define coordinates. You may still locate yourself relative to stars and galaxies. But none of these locations carry absolute meaning. They are conveniences layered onto a structure that does not recognize them. The universe does not have a middle where truth is clearer. It does not have a periphery where reality fades. It expands without reference, equally everywhere, indifferent to where you stand. You are not positioned within a grand design. You are simply somewhere, and somewhere, in a universe without a center, is all there ever is. Observational closure. All your evidence comes from light that has reached you. All your models are constrained by what you can observe. Infinite scale guarantees that decisive confirmation is impossible. Some questions cannot be answered, not because of technological limits, but because of the structure of reality itself. Knowledge encounters a boundary that cannot be crossed. You are trained to believe that uncertainty is temporary, that unanswered questions persist only until instruments improve, surveys expand, or methods refine. This belief has served science well. Many limits once thought fundamental turned out to be practical. Telescopes grew larger, detectors grew more sensitive, horizons receded. Cosmology confronts a different kind of limit. Every piece of information you possess arrives by one channel, signals that have had time to reach you: light, particles, gravitational waves. Nothing else can inform you. This is not a methodological choice. It is a physical constraint. Causality filters reality before it becomes evidence. As scale increases, this filter hardens. Regions beyond your horizon do not merely withhold information. They cannot, even in principle, supply it. No future experiment can alter that. No patient waiting can overcome it. The boundary is not technological. It is geometric. This produces observational closure, a condition in which theories can extend beyond evidence without ever being testable there. Models may predict structures, processes, or entire regions that exist outside all possible observation. Those predictions are not false. They are unconfirmable. You can test implications locally. You can check whether equations match what you see. But you cannot verify the global picture those equations suggest. Multiple incompatible cosmologies may agree perfectly within your observable universe, while diverging radically beyond it. Observation cannot choose between them. This challenges a core assumption about knowledge, that sufficient data eventually settles disputes. In an infinite or eternally inflating universe, some disputes persist forever. They are not waiting for resolution. They are immune to it. You may try to elevate mathematical consistency as a substitute. Perhaps the correct theory is the most elegant, the most economical, the most unified. But elegance is not evidence. It is preference. Consistency narrows options, but it does not single one out when several are equally coherent. From your position, this introduces a quiet asymmetry. The universe may be fully determinate in its total structure, yet permanently underdetermined by observation. Reality may have facts that cannot be known as facts. Truth exists without access. This does not mean science fails. It means science reaches a domain where its success changes character. Theories become maps of possibility rather than inventories of reality. They tell you what could be the case without confirming what is. You can still reason. You can still constrain. You can still falsify local claims. But global closure remains. The largest questions about total extent, ultimate structure, and complete inventory may never receive decisive answers. This is not because the universe is hidden. It is because it is too large for the method that discovers it. The unsettling implication is not ignorance, but permanence. There may be no future in which these limits dissolve. No civilization, no intelligence, no expansion of perspective that bypasses causality. Knowledge ends where influence ends. You continue to build models because understanding locally still matters. Predictions still work. Technologies still function. Meaning still emerges within the domain you can access. But the idea of final knowledge retreats. You cannot stand outside the universe to see it whole. You cannot collect enough viewpoints to reconstruct it. You cannot wait long enough for it to reveal itself. Observational closure is not a failure of patience. It is a feature of scale. What remains is a form of understanding that accepts incompleteness without resolving it. You know where your knowledge stops, and you know that beyond that point, reality does not become simpler. It simply becomes unreachable. The boundary is not marked by darkness or silence. It is marked by the absence of possible evidence. And beyond it, the universe continues, unconcerned with whether it is ever confirmed. Simulation as a scale. Compression 1 response to infinite complexity is the idea that reality is a simulation, not as fiction, but as an explanation for why observed physics appears discretized and computational. If true, the scale you perceive may be an abstraction, a rendered subset of something larger, or smaller, or fundamentally different. Scale may be an interface, not a property. You are accustomed to thinking of scale as intrinsic. Distance exists because space exists. Size exists because objects occupy volume. Time flows because events succeed one another. These features feel native to reality, not imposed upon it. The simulation hypothesis reframes this assumption. In many areas of physics, the universe behaves as if it is discretized. Energy comes in quanta. Information appears bounded. There are limits to resolution, to speed, to the amount of information that can be contained within a region. These limits resemble constraints familiar from computation, not from continuous substance. This resemblance alone proves nothing, but it motivates a question. What if the complexity you observe is not fundamental, but compressed? What if the apparent scale of the universe is a managed representation, not the full structure that underlies it? In a simulated system, scale is not absolute. A vast environment can be generated from compact rules. Large distances can be represented without being physically instantiated in full detail. Regions can exist only when observed. Resolution can vary depending on context. If reality functions this way, then the infinite scale suggested by cosmology may be misleading. What appears infinite may be procedurally extended. What appears continuous may be dynamically generated. The universe may not contain all of its scale at once. It may produce it as needed. From your perspective inside such a system, scale would feel real. Distances would be measurable. Expansion would be observable. Horizons would exist. But these features would be part of the interface, not the substrate. This idea becomes more tempting as cosmology accumulates infinities, infinite space, infinite universes, infinite repetitions. Simulation offers a way to contain these infinities without instantiating them fully. It replaces literal infinity with algorithmic potential. That replacement comes at a cost. If scale is an interface, then your measurements do not probe the deepest level of reality. They probe the rules of representation. The laws you infer describe how the simulation behaves, not what ultimately exists. This shifts the meaning of explanation. When you ask why constants have certain values, the answer may lie outside the simulated environment. When you ask why the universe has this scale rather than another, the answer may be that scale is adjustable. You might object that this merely relocates the problem. A simulation requires a simulator, a substrate, a larger reality with its own laws and scales. That is true. The hypothesis does not eliminate the need for explanation. It compresses it. But compression itself is the point. Simulation treats apparent infinity as an emergent artifact rather than a literal feature. It explains why complexity appears unbounded without requiring it to be instantiated everywhere at once. From the inside, this is indistinguishable from reality as you know it. A simulated observer experiences continuity, causality, and scale exactly as a non-simulated one would. There is no internal test that definitively reveals the interface. This makes the idea unsettling rather than comforting. It does not rescue meaning. It undermines certainty about what scale refers to at all. You may be tempted to dismiss the simulation hypothesis as speculative, but it arises naturally from attempts to reconcile infinite complexity with finite description. It is not a story imposed from outside. It is a response to scale becoming unmanageable. If the universe is a simulation, then infinite extension may be virtual. Repetition may be cached. Horizons may be rendering limits. None of this changes your experience. It changes what your experience is evidence of. Scale, in this picture, is not a measure of how much reality exists. It is a parameter of how reality is presented. You still live in rooms. You still look out at galaxies. You still measure distances and durations. But those measurements no longer guarantee that what you are measuring is fundamental. The unsettling implication is not that reality is fake. It is that scale may not be what you think it is. What feels like the size of existence may be the size of an interface you cannot step outside. And beyond that interface, if anything exists at all, scale may not resemble anything you recognize. Mathematical universes. Some physicists propose that all mathematically consistent structures exist, not physically instantiated, but real in a deeper sense. If reality is mathematical, then scale is unlimited by physical constraint. Every possible universe exists as a formal structure. Existence becomes unbounded by space or time. You are used to thinking of mathematics as a language, a tool you use to describe what exists. Equations model motion, numbers encode measurement, geometry represents space. Mathematics feels secondary, a map laid over territory that exists independently of it. The mathematical universe idea inverts this relationship. In this view, mathematics is not a description of reality. It is reality. Physical existence is just one way that a mathematical structure can be experienced from the inside. What you call the universe is a particular solution, not the container of all solutions. This proposal arises from a quiet observation. The laws of physics are mathematical. They do not merely approximate behavior. They define it with exactness that experiments confirm to extraordinary precision. The more deeply you probe reality, the more it resembles a formal system rather than a collection of substances. If that resemblance is not accidental, then there is no reason to privilege one mathematical structure over another. Any structure that is internally consistent exists in the same sense, not somewhere in space, not at some time. It exists because it is well defined. In such a framework, scale explodes. Every possible universe with different dimensions, constants, symmetries, and laws exists as a mathematical object. There is no requirement that it be realized through inflation, simulation, or physical process. Existence does not need to be generated. It simply is. This removes all constraints that physical cosmology struggles with. There is no need to explain why there are infinitely many universes. There are infinitely many mathematical structures by necessity. There is no need to explain why laws vary. They vary because different structures encode different rules. From your perspective, this is both clarifying and destabilizing. Clarifying, because it removes arbitrariness. Nothing needs to be selected. Everything that can exist does exist. Destabilizing, because it dissolves the idea that your universe is special, even in principle. You are not located at a privileged point in physical space. In a mathematical multiverse, you are not even located in a privileged structure. You exist inside one formal system among uncountably many. Your experience of scale becomes parochial. The vast distances and times you measure are features of one structure's internal geometry. They do not define the extent of existence itself. Existence has no metric, no size, no duration. This reframes the meaning of reality. To exist is not to occupy space or persist through time. It is to be mathematically coherent. Space and time are properties some structures contain, not prerequisites for being real. The unsettling implication is that physical explanation bottoms out not in matter or energy, but in abstraction. When you ask why something exists rather than nothing, the answer becomes that nothing is not a structure. Something is. This view also dissolves the idea of creation. Mathematical structures do not come into being. They are not caused. They are timeless. Your universe did not begin in a deep sense. It is simply one structure with an internal notion of beginnings. You may object that this strips reality of substance, that equations cannot feel pain, observe stars, or wonder about existence. But from the inside of a mathematical structure complex enough to encode observers, experience arises naturally. Subjectivity becomes an internal feature, not an external addition. In this sense, you are not inhabiting mathematics. You are mathematics experiencing itself from within. Scale, then, is no longer a question of how much reality there is. It is a question of which structure you find yourself in. Infinite space, infinite time, and infinite universes become small ideas compared to an infinity of formal possibilities. The unsettling conclusion is quiet. There may be no ultimate physical universe, no final container, no largest thing. There may only be an unbounded landscape of structures, all equally real, with no external reason to prefer one over another. And you exist inside one of them, measuring its distances, tracing its history, calling it the universe, while beyond it lies not emptiness, but unlimited mathematical existence that never needed space to begin with. Identity across infinite copies. If identical versions of you exist elsewhere, what defines your identity? Is it location, continuity, memory, causality? Infinite scale dissolves the uniqueness you assume. You are not a singular outcome. You are one instance among uncountably many. Selfhood becomes a local coincidence. You tend to define yourself through continuity. You are the same person you were yesterday because there is an unbroken chain of memory, body, and experience connecting those moments. Identity feels like persistence through time, anchored to a specific place in the world. Infinite scale complicates this intuition. If the universe is infinite, or contains infinitely many regions where physical conditions repeat, then versions of you exist that are physically indistinguishable, not metaphorically similar, exactly the same down to neural states, memories, and perceptions. From the inside, each one feels identical to you now. These copies do not branch from your choices. They do not diverge from a shared past. They arise independently, instantiated by the same physical laws operating across vast space. There is no causal link between you and them, and yet there is no physical difference either. This forces a question you are not used to asking. What precisely makes you you? If identity is defined by physical structure, then all identical copies qualify equally. If identity is defined by memory, then each copy remembers being you. If identity is defined by subjective experience, then each one experiences the same first-person perspective. Location seems like the only remaining distinction. You are here, they are elsewhere. But location is not an intrinsic property of a person. It is a coordinate, and coordinates in an infinite universe are arbitrary labels without global meaning. You might appeal to causality. You are the version connected to a particular past, but each copy has its own past, internally coherent, matching yours up to the point of duplication. From the inside, causality feels intact in every case. No copy experiences itself as causally ungrounded. This erodes the idea that identity is singular in a deep sense. It may be singular locally, because you only experience one chain of events. But globally, identity fragments into multiple instantiations that are equally valid. You are not duplicated in the way a photograph is copied. You are instantiated multiple times by the same rules. The universe does not track originals. It does not preserve authenticity. It allows states to exist wherever conditions permit. This does not create confusion for experience. Each version lives a separate life, unaware of the others. There is no overlap of consciousness, no shared awareness. From the inside, identity feels intact and exclusive. The problem arises only when you step back and consider scale. If selfhood depends on uniqueness, infinite scale removes that foundation. You are not unique because the universe does not guarantee uniqueness. It guarantees only consistency. Identity becomes a property of perspective, not of existence. This reframes questions about meaning and responsibility. You make choices. Those choices matter within your causal chain. But elsewhere, identical choices may be made by identical versions of you, with identical reasons and identical outcomes. Your decisions are not singular events in reality. They are local occurrences. This does not render them meaningless. It renders them non-exclusive. You may resist this conclusion by insisting that identity is tied to this particular stream of consciousness. But that stream exists in each copy, indistinguishable from the others. There is no internal marker that labels one as the real one. The unsettling implication is not that you are replaceable. It is that replacement does not apply. There is no original to be replaced. There are only instances. Selfhood, in this picture, is not a fundamental feature of the universe. It is an emergent one. It arises when matter organizes in certain ways and persists through certain processes. It does not carry a unique identifier. You continue to experience yourself as a singular being because experience itself is local. It cannot access its copies. It cannot feel duplication. Identity feels absolute because it is bounded by causality. But beyond that boundary, scale dissolves exclusivity. You are not one among many because you are special. You are one among many because nothing prevents it. And the sense of being a single, irreplaceable self may be less a statement about reality than a consequence of being confined to one location within it. The collapse of global meaning. Meaning often relies on context, on position within a larger structure. Infinite scale removes that context. There is no overarching narrative, no total system to belong to. Only local processes repeating endlessly. Purpose does not scale. You are accustomed to finding meaning by reference. Events matter because they fit into something larger. Actions matter because they contribute to an outcome. Lives matter because they occupy a place within a story that extends beyond them. Meaning, as you experience it, depends on placement. Finite systems provide this naturally. A beginning implies an end. A center implies orientation. A boundary implies inside and outside. Within such structures, purpose emerges almost automatically. Things can aim toward completion, improvement, or resolution. Infinite scale removes these anchors. If the universe has no total boundary, no final state, no global trajectory, then there is nothing for existence as a whole to be oriented toward. Processes continue, but they do not converge. Events happen, but they do not accumulate into a final outcome. History extends, but it does not progress toward a conclusion. From your perspective, this undermines the idea of a universal narrative. There is no story the universe is telling, no direction it is moving in, no objective against which actions can be measured on a cosmic scale. What happens here does not advance the universe toward anything. This does not mean that events are random or lawless. Local order persists. Stars form. Life evolves. Civilizations rise and fall. But these processes do not add up to a global purpose. They repeat endlessly across space and time without contributing to a larger whole. Meaning becomes local. Your actions matter within your environment. Your choices affect those around you. Your projects have outcomes within finite contexts. But beyond those contexts, their significance does not extend. The universe does not register them. It does not preserve them. It does not require them. This realization can feel destabilizing because it conflicts with an inherited expectation. That meaning should scale up. That what matters locally should matter globally if examined from a sufficient distance. Infinite scale denies this escalation. In an infinite universe, no event is singular. No achievement is final. No failure is decisive. Every configuration recurs elsewhere. Every outcome is replicated. Nothing changes the total structure because the total structure has no final state to change. This collapses the idea of global meaning without touching local significance. The two are not the same. Meaning can exist without being universal. Purpose can operate without being cosmic. The discomfort arises when you try to project local meaning outward, when you ask what it all adds up to. In an infinite universe, the answer may be that it does not add up at all. It simply continues. This is not nihilism imposed from outside. It is a consequence of scale. When there is no final context, there is no final justification. Meaning does not disappear. It loses its claim to universality. You may try to recover global meaning by appealing to structure itself. Perhaps the universe's purpose is to exist, or to generate complexity, or to explore possibility. But in an infinite system, these descriptions lose force. Everything that can happen already happens. There is nothing left to achieve. You may appeal to observation. Perhaps meaning exists only where observers exist. But observers are local features. They do not confer purpose on regions they cannot affect. They do not unify the whole. What remains is a universe that functions without a goal, not because it is broken, but because it does not require one. Processes unfold because conditions allow them to, not because they serve an end. The unsettling implication is subtle. It is not that your life lacks meaning. It is that the meaning it has does not extend beyond its causal reach. There is no higher frame that redeems or condemns it. You live inside a local narrative, embedded in a finite context, within an infinite background that does not participate in that narrative. Your purposes operate. They motivate. They matter to you and to others nearby. But they do not accumulate into a cosmic purpose. Purpose does not scale because scale does not care, and the universe, vast and unbounded, continues without asking what it is for. Observers without history. In infinite models, observers can arise without evolution, without past, without cause beyond fluctuation. Their experiences feel real. Their memories feel coherent. Your certainty about history relies on assumptions about probability that infinite scale erodes. The past becomes less secure than you think. You trust the past because it appears continuous. Memories align with records. Records align with physical traces. Fossils, radiation, documents, scars, and habits all point backward along a chain of causes. This coherence convinces you that history is not only remembered, but real. Infinite scale weakens that conviction. In cosmological models where space or time is unbounded, the mechanisms that allow Boltzmann brains also allow something subtler. observers whose internal states encode an apparent history without that history ever occurring. Not merely false memories, but entire inferred pasts supported by consistent internal evidence. From the inside, such an observer experiences no contradiction. Their memories agree with their perceptions. Their beliefs align with their environment. Everything that normally counts as evidence of a past is present. The only thing missing is the past itself. You might assume that such observers are fantastically rare. But rarity loses meaning in infinite contexts. Even events with vanishingly small probability occur endlessly when the arena is large enough. What matters is not how unlikely an outcome is, but whether it is permitted at all. This introduces a troubling symmetry. An observer who evolved through billions of years of cosmic history and an observer who fluctuated into existence with identical mental states are indistinguishable from the inside. Experience alone cannot tell them apart. You rely on probability to dismiss the second possibility. You assume that evolved observers vastly outnumber fluctuation-based ones. But as you have already seen, infinite scale disrupts that assumption. Counting becomes ambiguous. Typicality collapses. The balance between histories and non-histories becomes unclear. This uncertainty reaches backward into your own past. You believe that the universe existed yesterday because you remember it. You believe it existed millions of years ago because you see stars and fossils. But these inferences assume that such evidence is more likely to arise from a real history than from a spontaneous configuration. In finite systems, that assumption is safe. In infinite systems, it becomes conditional. The unsettling implication is not that your past did not happen. It is that the justification for believing it did becomes less absolute. History shifts from being a fact you can verify to a hypothesis that fits your experience. You may object that this skepticism goes too far, that denying history undermines science, meaning, and reason itself. That is true, and that is precisely why these models are disturbing. They force you to recognize that your confidence in the past is not derived solely from logic, but from pragmatic necessity. You assume the past because you must. Without that assumption, no reasoning survives. Infinite cosmology does not tell you that history is false. It tells you that history is not guaranteed by experience alone. It is guaranteed by a framework that works locally and is trusted globally, even when global justification weakens. This creates a fragile position. You continue to reason, to remember, to infer, while knowing that the largest possible context destabilizes the foundations of those inferences. You live as if history is secure, while understanding that security may not scale. The idea of observers without history also reframes what it means to exist at all. Existence may not require a past. Consciousness may not require development. Experience may arise fully formed without narrative support. Your sense of self is bound to continuity, to growth, to cause and effect unfolding over time. Infinite scale allows for selves without any of that, indistinguishable in experience from you. You cannot rule this out empirically. You cannot verify that your past occurred by stepping outside your experience. You can only note that assuming it did produces coherent understanding and functional action. The unsettling conclusion is quiet. Your trust in history is not disproven. It is contextualized. It works where you are, under the assumptions you live by. Beyond that context, in the full scope of infinite possibility, the past becomes less of a certainty and more of a condition you rely on without final proof. You continue to remember. You continue to believe. but scale ensures that belief, like everything else, rests on ground that is not as solid as it feels. The universe as process, not object. Rather than a thing, the universe may be an ongoing process with no total state, no completed description, no final snapshot. Scale prevents closure. Reality never finishes existing. You are embedded within an unfinished system. You tend to think of the universe as an object, something that exists all at once, even if you can only observe part of it. You imagine that, in principle, there is a complete description waiting to be written, a final map, a total inventory of what exists. This assumption feels natural because most things you interact with are objects. They have boundaries. They can be fully specified. Even when they change, you can describe their state at a given moment. You carry this intuition outward and apply it to reality itself. Modern cosmology resists this framing. In many models, the universe is not a static entity evolving through time. It is a generative process. Space expands, regions decouple, structures form and dissolve. New domains emerge while others become causally irrelevant. There is no global moment at which everything can be said to exist simultaneously. A process does not have a total state in the way an object does. You cannot freeze it and capture it whole. Any snapshot you take is local, temporary, and incomplete. The moment you try to describe the entirety, the process has already moved beyond that description. Scale intensifies this problem. In an infinite or eternally inflating universe, there is no final configuration toward which reality settles, no equilibrium state that marks completion. The universe does not converge, it proliferates. This means that the idea of a finished universe may be incoherent. There is no completed reality waiting to be known. There is only ongoing generation, unfolding without a terminating condition. From your perspective, this changes what explanation means. You often ask what the universe is. But if the universe is a process, the more appropriate question is what it is doing. And that question has no final answer, because the doing does not end. You are accustomed to histories with beginnings. Cosmology once offered that comfort through the idea of a Big Bang. But even that beginning, in many models, is not an absolute start. It is a transition within a larger process, one phase giving way to another. If there is no absolute beginning and no final state, then reality lacks the narrative structure you expect. There is no opening scene, no closing frame, no complete story to tell. You exist within this process, not outside it. You do not observe the universe from a distance. You are one of its transient configurations, embedded in its ongoing activity. Your measurements capture moments. Your theories describe patterns. None of them halt the process to reveal a whole. This undermines the idea of ultimate knowledge. Even in principle, there may be no total description to arrive at. Any attempt to summarize reality must leave something out, not because of ignorance, but because reality itself is unfinished. The unsettling implication is that incompleteness is not a temporary condition. It is permanent, not as a failure of understanding, but as a feature of what is being understood. You may try to imagine a higher-level description that captures the process itself. A set of rules that governs all generation, but even such rules do not constitute a total state. They describe how reality unfolds, not what it ultimately is. In this view, existence is not something that has happened. It is something that is happening. There is no point at which the universe can be said to fully exist, because existence is distributed across time and scale without closure. This reframes your position. You are not living in a completed cosmos, waiting to be deciphered. You are participating in an ongoing event that does not resolve into a final form. Your questions, your observations, your theories are part of that process. They arise, function locally, and pass. They do not culminate in a definitive account. The universe does not wait to be known. It does not pause to present itself. It continues, and you, embedded within it, seek understanding inside a system that never finishes becoming what it is. Limits of explanation. Scientific explanation depends on compression, on summarizing vast phenomena with compact laws. Infinite scale resists compression. Theories grow longer, not simpler. Explanation becomes enumeration. Understanding stretches until it breaks. You rely on explanation to reduce complexity. A good theory takes many observations and unifies them under a small set of principles. It tells you not just what happens, but why it happens without listing every instance. Compression is what makes knowledge portable. It is what allows understanding to travel beyond the data that produced it. This strategy works because the world you usually study is finite in relevant ways. Systems repeat. Regularities dominate. Noise can be averaged out. Laws emerge because patterns recur more often than exceptions. Infinite scale disrupts this economy. When the universe is unbounded, regularities do not necessarily dominate. Every exception occurs endlessly. Every rare configuration repeats without limit. A theory that attempts to account for all outcomes cannot privilege one over another without additional assumptions. Compression fails because there is nothing to compress toward. You see this when explanations begin to inflate. Instead of one law describing many outcomes, you get a framework that allows every outcome. Instead of prediction, you get accommodation. The theory becomes a catalog of possibilities rather than a constraint on reality. At that point, explanation starts to resemble enumeration. To explain why you observe this universe rather than another, the theory must list all universes and then note that yours is among them. Nothing is ruled out. Nothing is singled out. The explanatory work is done by inclusion, not exclusion. This is not a failure of rigor. It is a consequence of scale. As the domain of explanation grows, the criteria that once made explanations powerful weaken. Simplicity no longer guarantees insight. Generality no longer narrows expectation. A theory can be mathematically elegant and still fail to tell you what to expect. From your perspective, this creates a tension between truth and usefulness. A theory may be true in the sense that it accurately describes a process that generates all outcomes. But it may be useless in the sense that it cannot explain why any particular outcome occurs here rather than elsewhere. You can still derive local predictions. You can still explain why stars form, why atoms bond, why time flows forward in your region. But when you ask why the universe has this structure rather than another, the answer may be that all structures exist. Explanation ends not with a reason, but with exhaustion. This stretches understanding in a specific way. You do not encounter contradiction. You encounter excess. Too much reality, not too little. The theory does not break because it is inconsistent. It breaks because it cannot be summarized. You may try to impose new criteria. Perhaps the correct explanation is the shortest description, or the most computationally efficient, or the one that minimizes information. But these are external standards. They do not arise naturally from the universe itself. They reflect your preference for manageability. Infinite scale resists being managed. The unsettling implication is that explanation may have a horizon, just like observation. Beyond a certain scale, asking why may no longer yield a satisfying answer. Not because the question is illegitimate, but because the structure of reality does not support compression at that level. You can still explain mechanisms. You can still trace causes locally. But global explanation becomes diffuse. It loses its power to discriminate. Understanding stretches outward, accumulating detail, until it no longer clarifies. This does not mean that science fails. It means that its success has limits shaped by the size of what it studies. Science excels at finite patterns. It struggles with totalities that contain everything. You are left with theories that work perfectly where you can test them and grow increasingly abstract where you cannot. They remain coherent. They remain consistent. But they stop feeling explanatory in the way you expect. Understanding does not collapse suddenly. It thins. You still know how things behave. You may no longer know why this is the behavior you see. The universe stops offering reasons and starts offering allowances. At that point, explanation changes character. It becomes a description of possibility rather than a justification of actuality. And you are left to navigate a reality that can be described without being fully explained, where understanding reaches outward until scale itself becomes the limiting factor. The silence of verification. Many of these ideas cannot be tested directly, not because they are unscientific, but because scale places them beyond observation. Science reaches a point where coherence survives, but confirmation does not. Truth becomes conditional. You are used to thinking of science as something that ultimately resolves questions. Hypotheses are tested, predictions are checked, experiments decide between competing ideas. Even when answers take time, there is an expectation that evidence will eventually speak. At large enough scales, that expectation fails quietly. The theories you have encountered are not incoherent. They are mathematically precise. They follow from established principles. They fit all available data. What they lack is not rigor, but access. The regions they describe cannot send signals. The events they predict cannot leave traces. Verification is not delayed, it is excluded. This creates a new epistemic condition. A theory may be internally consistent and empirically adequate within your observable universe, yet make claims about reality that can never be checked. These claims are not speculative in the casual sense. They are consequences of the theory itself. But they lie outside the reach of any possible experiment. You cannot build a detector large enough to see beyond a cosmic horizon. You cannot wait long enough for causally disconnected regions to communicate. No refinement of method changes this. Scale imposes a silence that no ingenuity can overcome. Science does not collapse here. It changes character. Within the observable domain, the scientific method works as expected. Predictions succeed. Measurements converge. Explanations remain powerful. Beyond that domain, theories continue to speak, but the universe no longer answers. Confirmation gives way to consistency. You may try to rank theories by indirect criteria. Which one is simpler? Which one unifies more phenomena? Which one avoids paradox? But these criteria do not function as tests. They guide preference, not truth. They help you choose a framework, not verify a claim. This creates a subtle shift in what it means to know something. Knowledge becomes conditional on perspective. A statement may be true given the theory you accept, and unaccessible beyond that. Truth is no longer anchored to observation alone. It depends on the structure of inference. You might resist this by insisting that untestable claims are meaningless, that science should restrict itself to what can be verified, but the theories in question do not allow such restriction cleanly. Their untestable consequences are inseparable from their testable successes. To reject one is to undermine the other. You are left with a choice that is not empirical. Accept the theory with its silent regions, or reject it and lose its explanatory power where evidence does exist. Neither option restores verification. This is not a failure of honesty. It is an encounter with scale. The unsettling implication is that some truths about the universe may never be known as truths. They may be coherent, unavoidable, and yet permanently unconfirmed. The universe may possess properties that no observer can certify. From your perspective, this demands restraint. You can believe a theory is likely. You can treat it as provisionally correct. You can use it to guide further inquiry. But you cannot elevate all of its consequences to established fact. Truth becomes layered. Some statements are confirmed, others are supported, others are consistent, and some remain silent, neither verified nor falsified. This silence is not temporary. It is structural. You may still speak about these ideas because they organize understanding. They provide context. They explain why the universe you see has the features it does. But explanation now operates without closure. It gestures beyond what can be checked. Science reaches a boundary where it no longer converges on a single, verifiable picture of total reality. Instead, it offers frameworks that extend into regions where evidence cannot follow. You continue to reason because reasoning still works locally. You continue to test because testing still matters. But at the largest scales, you accept a condition that earlier science rarely confronted, that coherence may be the highest standard available. The universe does not contradict you. It simply does not respond. And in that silence, knowledge persists without confirmation, truth without proof, understanding without final endorsement. What remains is not ignorance, but an awareness of where certainty ends and where the universe, vast and unreachable, declines to speak further. Local reality as an accident. Your region of space may be a rare outcome among infinitely many. Its stability, structure, and laws may be statistical anomalies. You exist not because reality favors you, but because scale allows everything. Existence becomes unsurprising. You are inclined to interpret order as intention. When conditions align just enough to support complexity, you suspect a reason. When laws appear finely balanced, you infer necessity. Stability feels earned, as if reality has arranged itself this way for a purpose. Infinite scale offers a different explanation. If reality contains infinitely many regions, then every permitted configuration exists somewhere, not because it is likely, but because it is allowed. Stability does not need to be common. It only needs to occur. Once it does, observers inevitably arise within it and notice how improbable their circumstances seem. From your position inside such a region, the universe looks remarkably hospitable. Constants fall within narrow ranges. Structures persist long enough for complexity to develop. Time unfolds slowly and predictably. These features invite interpretation. They feel meaningful. But in an infinite landscape, meaning is not required for occurrence. Your universe may be one of the few regions where conditions happen to settle into a long-lived, structured state. Elsewhere, laws may fluctuate too violently. Expansion may tear matter apart. Collapse may end regions before complexity emerges. These regions contain no observers to remark on their instability. You do not find yourself in a stable universe because stability is typical. You find yourself there because only stable universes contain finders. This reframes the idea of explanation. Instead of asking why the universe is like this, the answer becomes that universes like this are the only ones that get asked about. Existence does not require preference. It requires permission. The unsettling aspect of this view is not that your universe is rare. It is that rarity ceases to be explanatory. Being unlikely no longer demands a cause when the sample size is infinite. Improbability loses its force as an argument. This undermines the intuition that order needs justification. In a finite system, it does. In an infinite system, order can be an accident that repeats endlessly somewhere. You may resist this conclusion because it feels dismissive, as if your existence is reduced to chance. But chance is not the right word. In infinite contexts, chance dissolves into certainty. Everything that can happen does happen, not eventually, always. Your universe is not selected. It is instantiated. This also affects how you think about necessity. You often assume that if something exists, it must exist. That the laws you observe are somehow compelled. Infinite scale replaces compulsion with contingency. Things are the way they are here, because they could have been otherwise elsewhere. This does not make your reality fragile. It makes it unprivileged. You continue to experience consistency, causality, and reliability. Those features hold locally. They are not illusions, but they do not extend beyond your region. They are not guarantees written into reality as a whole. The deeper implication is that explanation no longer points upward. There is no deeper reason why your universe has these properties. There is only a broader context in which all properties occur. Existence becomes unsurprising, not because it is trivial, but because it is inevitable somewhere. This shifts the emotional weight of understanding. Wonder does not disappear, but it loses its teleological direction. The universe does not appear arranged, it appears permissive. You exist not as a favored outcome, but as a permitted one. The same laws that allow your world also allow worlds where nothing lasts, where nothing observes, where nothing reflects. Those worlds are invisible to you because nothing within them asks questions. Your world asks questions because it persists long enough to do so. In an infinite reality, that persistence is not a goal achieved. It is an accident repeated. You may still find meaning in that accident. You may still value the conditions that allow you to exist, but the universe does not share that valuation. It does not preserve your region because it is special. It allows it because it allows everything. And in that allowance, existence loses its aura of necessity and gains a quieter, more unsettling character. You are here not because the universe intended it. You are here because nothing prevented it. Scale without end. If the universe has no upper bound, then inquiry itself has no final answer. Every explanation opens onto a larger context that cannot be contained. Scale does not conclude. It overwhelms, and you remain inside it, asking questions that have no global frame in which to settle. You have been trained to expect closure. Questions invite answers. Problems resolve. Explanations terminate in principles that feel fundamental. This expectation is not naive. It has been rewarded repeatedly. Many domains of knowledge do converge. Many mysteries do collapse into understanding. Scale resists that pattern. Each time you extend your view outward, the context expands faster than your explanations can encompass it. You explain galaxies and discover larger structures. You explain those structures and encounter horizons. You explain horizons and confront processes that generate them endlessly. Understanding does not stop. It recedes. This is not a failure of effort or imagination. It is a structural feature of unbounded reality. In a universe without an upper limit, there is no final layer to reach, no ultimate scale at which explanation rests. Any account that seems complete is revealed, from a wider perspective, to be partial. You might hope for a final theory, a compact set of laws from which everything else follows. But even if such a theory exists, it does not close inquiry. It explains how reality unfolds, not why this unfolding has the extent it does. It does not delimit scale, it operates within it. If scale is infinite, then explanation is recursive. Every answer generates new questions at a higher level. Why these laws? Why this structure? Why this process rather than another? Each why opens onto a broader landscape that cannot be exhausted. This creates a quiet inversion. Knowledge does not accumulate toward completion. It accumulates toward awareness of incompletion. Understanding becomes deeper, but not final, more coherent, but not closed. From your position, this alters the meaning of inquiry itself. You are not moving toward a destination. You are navigating an endless terrain. Progress is real, but it does not terminate. There is no summit from which the whole can be seen. This does not render inquiry futile. It renders it unfinishable. The unsettling implication is that some questions are not unanswered because you lack information. They are unanswered because the structure of reality does not permit a final answer. Asking them is not a step toward resolution. It is an engagement with infinity. You continue to ask because asking still matters locally. You still learn. You still predict. You still build understanding within finite domains. But the expectation that all understanding converges into a single, global frame dissolves. Scale overwhelms, not by obscuring, but by extending beyond containment. Reality does not withhold answers. It provides too much context for any answer to be final. You may try to impose closure by redefining the scope of inquiry, by declaring some questions meaningless, by restricting science to what can be tested. These moves restore manageability, but at the cost of completeness. They are pragmatic boundaries, not ontological ones. The universe itself does not respect them. If there is no upper bound, then the universe does not present itself as a problem to be solved. It presents itself as a condition to be navigated. Understanding becomes an ongoing practice rather than an achievement. You remain inside this practice. You ask questions knowing they open outward. You build explanations knowing they are provisional. You seek coherence, knowing it will never be total. This is not a pessimistic conclusion. It is a reorientation. Inquiry does not fail, because it does not finish. It functions because it continues. The universe does not offer a final perspective from which everything aligns. It offers only local vantage points, each embedded within larger contexts that cannot be fully grasped. You stand within one of those vantage points now, thinking, measuring, questioning. Beyond it, scale extends without end, indifferent to whether it is ever contained by understanding. And so you continue, not toward an ultimate answer, but within an unbounded reality where asking is the only stable position. Scale does not conclude. It surrounds you.